Hey everyone, welcome to another episode of the Tractable podcast. I'm Shatej, co-founder and CTO here at Orb. Today I have with me Richie. Richie is the co-founder at WarpStrem. WarpStrem is a Kafka-compatible data streaming platform, and WarpStrem is doing a ton of cool stuff on top of S3. And Richie has worked at Datadog and Uber before, working on lots of big data streaming problems. So really excited to have Richie. Richie, welcome to the show.
Thanks for having me, man. Really excited to be here.
Awesome. Well, let's just start a little bit with your background and what inspired you to start WarpStream. As I just said, you've clearly worked in parts of this technology at previous companies. So give me a little bit of that play by play and how you've thought about this problem, perhaps in previous roles in your career.
Yeah. I've been working in distributed storage for most of my professional career at this point. So like 9 years or something. Kind of got started almost all focused in the observability space too. So I kind of got started in storage at Uber, working on when Uber was going through their kind of like hyper growth phase, they had a bunch of internal observability technology. I mean, they still do. And there was an internal metrics platform called M3 that I worked on. That technology, it was open source and eventually became the company that is Chronosphere. And so they had a distributed open source time series metrics engine and distributed time series aggregation thing. And so I worked on that for about 3 years, um, you know, mostly on the kind of guts and internals of the database. That was a really different system than WarpStream 2. That was very much like it does all the replication itself. It interacts with raw disks, kind of like classic distributed system. Interestingly enough, when we were at Uber, the observability teams actually couldn't like afford to use Kafka. Like the whole company
Hmm.
used Kafka, but it just like the amount of data we were pumping through, we just like wasn't cost effective. And so,
Hmm.
at least at the time, the M3 team created this thing called M3 Message, which is kind of like you can think of like just the in-memory part of Kafka. If
Right.
the buffers fill up because there's too much back pressure, then you have to drop metrics, and that's life. Um,
Yeah.
so that was kind of like my first kind of encounter with streaming is for these kind of like big data systems. After that, my co-founder and I, Ryan, we met at a conference actually while I was still working at Uber.
Yeah.
Um, and Ryan's like a big kind of distributed systems nerd. He reads all the papers and knows all the, can explain the exact nuances between Paxos and Raft and all that type of
Yeah.
stuff. At the time, tried to convince me that we should either build um, a logging database on top of object storage, or we should build
Hmm.
Kafka on top of object storage, just like 5 years ago.
Hmm.
And I was like, Kafka object storage, who cares? That sounds so boring. We don't even use Kafka for our metrics. It's fine.
Yeah.
Let's do logging. That sounds cool. And so we built, like a prototype of a system, and that system eventually became a system called Husky at Datadog, which is essentially um, the kind of columnar store that
Hmm.
powers most of Datadog's storage products.
Hmm.
Everything that's not metrics basically goes into Husky logs, network events, profiling, APM, all that sort of stuff.
Yeah.
And it's basically a giant, you can think like Snowflake, but for observability data or, that sort of thing.
Yeah.
Kind of very similar architecture to WarpStream, fully stateless, separation of data or compute and storage and all that type of stuff. And what was interesting at Datadog, I learned, was like they use Kafka for everything.
Right.
There's tons of Kafka pipelines that they do for processing and stuff like that. And what I learned was like how nice it is to have this like really scalable, durable buffer. If you can
Yeah.
afford to use it, and it just made developing Husky so much easier because it's this static buffer that doesn't change too often, so you can kind of change all the software around it. If you mess up
Yeah.
anything too bad, you can replay from Kafka, right? If you even think
Yeah.
about doing the migration, I mean, we had the old system reading from Kafka and Husky reading from Kafka. They both read the same data. You shadow
Yeah.
queries, and it's really straightforward, and you didn't have to worry that like if we had a buggy early build of Husky that would somehow impact the service that was powering all the real time stuff. And I was like, okay, wow,
Exactly.
this is great.
Yeah.
So that was super nice. And then we kind of finished migrating everything to Husky, the new system, saved tons of money, um, much smoother operations, stateless. It was great. And then when we were done, we were like, man, these Kafka pipelines are actually starting to feel really annoying compared to
Yeah.
Husky. Because we'd have some customer notify us that like, hey, we're having this event tomorrow, we're going to 10x in traffic or whatever,
Yeah.
and we'd be like, on the Husky team, we'd be like, we don't care, like it'll auto scale. Um,
Yeah.
but then like someone would have to go and manually scale the Kafka clusters, and once you
Yeah.
scale them back up, someone have to remember to scale them back down. And scaling down Kafka is not like a trivial thing to do.
Yeah.
You had to make sure everything was triply replicated, and if you had top leader election problems and zookeeper and all these things, right?
Yeah.
And we're just like, this doesn't make sense.
One thing that's interesting about both those experiences is that I think in order to get to the inspiration point for WarpStream, you really had to work on real problems at scale. Do you think
Yep.
that's true? Do you think it would have been hard to even dream up the idea of like, oh, let's build Kafka on object storage if you hadn't seen uh, organizations at the scale of Uber and Datadog really run into the kind of economic problems? Because that's not an experience that a ton of folks have coming into their startup, right?
Yeah, I think that's 100% true, and I think that's also kind of why Ryan and I think made such like a good pair also as co-founders, because he's like very deep in the weeds on the kind of like cutting edge theoretical what's possible. Can we like do the mapping path? Is this possible? And I had a lot
Yeah,
of that kind of like experience of just like grinding my head against a terrible problem in production and eventually coming
yeah,
out with like a really reliable system on the other
yeah,
end. And I think the two of us together kind of really allowed us to do something that was both, figure out how to operationalize what was essentially like a massively new architecture really quickly.
yeah, yeah,
But I agree, and I mean, Kafka is like a kind of also just like, I think I was joking about how like usage-based billing is like such an unsexy problem, um, and like that's kind of the value in solving it. I think Kafka is kind of similar. It's like this very kind of like enterprisey
yeah,
thing, and like the value is not obvious. I think to a lot of people who haven't dealt with like some of these problems at scale, but like if you've worked at these problems at scale, being able to like afford to use Kafka in the middle in your system somewhere is just like this huge, besides the problems of maybe with the open source version of like cost and operations, it gives you all these benefits
yeah.
that yeah are probably not obvious at like smaller scale.
So, let's talk a little bit about how WarpStream is built, and I have a follow up there around whether the trade offs that you've taken at WarpStream and kind of rebuilding Kafka on top of object storage, whether those made sense for Datadog and Uber, and which companies they make sense for. But maybe first let's just talk about architecturally. What is WarpStream? What's both the current product and perhaps like how are you thinking about it in the medium long term?
Yeah, so today WarpStream is designed to be a like drop-in replacement for Apache Kafka. So it supports the Apache Kafka protocol. If you have an application that works with Kafka, even like a UI admin tool for Kafka, you can connect it to WarpStream, and everything should just work. You might notice a couple quirks, just that we do things a little bit differently, but the semantics of your application should be pretty much exactly the same. And the value of that, I think, which is that like, kind of going back to the thing at Datadog where we finished migrating everything to Husky, when we were done, we were like, wow, is Kafka operationally really difficult, but also really expensive. Like the thing that
Yeah,
happens when you self-host Apache Kafka and you run it in 3 AZs, is that you spend a ton of money on inter-zone networking. And
yeah,
so while WarpStream is designed to be a drop-in replacement, the two things that it does that are kind of novel, is that it doesn't have any local disks. It uses object storage as the one and only storage in the system, like so
yeah.
not even tiered. And what that means is we never replicate data across availability zones ourselves,
Mm,
which
mm,
means you never pay those interzone networking fees, which can be
mm.
huge. At like for something like with Orb, for example, people are sending you all these events. At high volumes, the replication fees can dominate basically the workload.
Right,
And the
right.
other is just like the stateless nature of it, making it kind of like Husky, just trivially auto scale based on CPU. You can use smaller nodes because you're not over provisioning, and just let your auto scaler kind of take care of most things for you.
Yeah,
There's no topic partition leaders. Any agent can write data for any topic or
yeah,
partition. There's no zookeeper. There's no kraf. There's no embedded raf
yeah,
group.
yeah,
The agents are truly these kind of like thick stateless proxies.
yeah,
And so that's the product today. Where we're going, that's a good question. The thing I always tell the team, really, I don't like put this on the website because it's not like good positioning in the short term, but like the way we think about ourselves is more like we think of ourselves as a streaming company and a storage company, not like a
yeah,
Kafka company.
yeah,
Today, I think the highest value thing we can do for the streaming space and for our
yeah,
customers is give them something that implements the Kafka protocol and saves them a bunch of money and makes it easier for them to sleep through the night. But longer term, I think there are higher level products and abstractions um, that will make a lot of sense to kind of generalize some of the really common things that people do in the streaming space,
Yeah.
and kind of offer those as more kind of tightly knit products that are a little more
Yeah.
vertically integrated. But we'll
Yeah.
obviously always offer the Kafka protocol product because it's a really useful and scalable infrastructure primitive.
Yeah.
But it's not like our company identity.
And there's a couple of things you said there. One, of course, is the cost savings of the architecture, right? Like the fact that you don't have to do inner AZ replication. But the other thing you touched on is the fact that it is stateless, and it's in some sense, in some real way, it's a simpler architecture, or it's simpler to reason about. You don't have to think about Zookeeper. Um, which of those problems do you think is the higher order bit? Or when someone adopts WarpStream today, is it like, okay, it's kind of a barbell of, if you're a really large company, what you really care about is the fact that it's much cheaper. You don't pay the AZ replication costs. And maybe if you're a smaller team, you just want a product that is going to mean you don't get paged and have to reason about, guarantees that perhaps you're not familiar with. And so the stateless nature helps a lot.
Yeah, it's a good question. I People ask me that a lot too, and I think like the like canonical wisdom, right, is that to like supersede an established and kind of well-known product, the new thing has to be like 10 times better.
Yeah.
I think for like critical infrastructure like Apache Kafka, um, it has to be more than 10 times better. Like if you think
Yeah.
about like how popular people still run, single node RDS Postgres databases today,
Right.
right? Because it's
Right.
just like it's a really good product, and it's taken 30 years before we're even starting to see like some of this new
Yeah.
SQL stuff take off and people offering serverless Postgres and stuff. It's just taken that long because it's like
Yeah.
it's such a critical piece of infrastructure. It's so battle tested. It's so well known. You have to be that much better.
Yeah.
And I think with WarpStream, it's that too. It's like I think if any of the three things we did, if it wasn't 5 to 10 times cheaper, if it wasn't completely stateless and trivial to operate, and if it
Yeah.
didn't implement the Apache Kafka protocol product, so you can do like a
Yeah.
essentially seamless migration. If we hadn't done any one of those three things, I think it would probably have failed.
I
Not to
see.
say that we're like a massive success already, but I think I I think those three things are like a requirement for something to have a big disruption in this space because there's been a lot of other people have built a lot of other message brokers since Apache
Yeah.
Kafka was released.
Yeah.
Tons of them actually.
Yeah.
And I think either they were more complicated than Kafka or they were a little bit simpler but not that much cheaper, right? No one's going to do a massive
Yeah.
migration for 40% cost savings. Like that sounds cool,
Exactly.
but to a new architecture and I have to learn everything, like it's not enough.
Yeah.
Whereas today with WarpStream, or they invite some new protocol, right? That and it's like, well, now
Yeah.
my application doesn't work. And so with WarpStream, really, I think what tends to happen is like um, the engineers really what resonates with them is the simplicity and the operations. Like they're like, oh
Yeah.
yes, like S3, I know that. I like stateless
Yeah.
services. I know how to run those. Like we've got Kubernetes, do that all day.
Yeah. Yeah.
The cost savings tend to be the thing that kind of helps them push it through the organization, basically.
Hmm. Yeah.
And then also they also really like the Kafka protocol compatibility because they don't have to rewrite their application.
Yeah.
The cost savings thing too, though, is interesting, which is that like one thing people I think undervalue about like it's one thing if you take like some product that you use that you're paying per seat or something and you sell it 10 times cheaper. That's one thing. But making core infrastructure 5 to 10x cheaper means you can do new things, right? It's not just about like reducing your
Right.
spend.
Right.
Everyone's really focused on that right now, but it means like you can use this technology for things that it was previously cost prohibitive to use. And so suddenly, that
Yeah.
Uber metrics use case, um, or whatever, suddenly it becomes like actually it's more cost effective to send the data through
Yeah.
WarpStream than it is to manually send it across availability zones in memory, right? And
Yeah.
so
Yeah.
enabling the technology to be used in more places, I think that's kind of what I find more exciting. But obviously, being able to tell people, hey, your existing thing will work today and be cheaper is really cruel.
Yeah.
And then the slope per byte instead of being like this is like this, and now
Yeah.
you can put more data in it. So
Yeah. So let me actually ask the architecture question one level deeper, which is, this idea, let's take the Kafka protocol, let's build it on object storage, let's put everything on object storage, not have any tiering. And conceptually that sounds kind of simple. So what's the core insight? Like, why hasn't someone done this before? Why aren't you incurring like a ton of, API request cost in making requests to S3? Is it that S3's cost model has changed over the last year or two, and that's the timing bet, or is it that you all have been able to generate some learnings that maybe you had at these previous companies, and these are just non-obvious technical decisions that maybe other companies haven't thought of?
It's all of those things. I think this idea has been like ruminating in my co-founder Ryan's. The whole architecture and implementation was his idea, and it's been stewing in his brain for like 6 years. He's just been wanting to do this forever. I'll start with like the kind of primary insight I think that we made, and this is kind of where people describe our architecture as like aggressive, which is
Yeah,
that like we just looked at our careers and the workloads we know and all the use cases for Kafka, and we were like, if you look at like, let's say per byte, maybe not number of use cases, but like by raw bytes transmitted through systems like Kafka, more than 90% of that is not latency sensitive. It's latency sensitive in the sense that you want things to happen in seconds, but
yeah,
it's not like this message needs to get from the producer to the consumer in 5 milliseconds. And I'm willing to pay 10 times more and burn an entire 10-person engineering team to accomplish that, right? It's like,
yeah, yeah,
A, if the P99 from the producer to consumer was 1.5 seconds, would your business function just as well? And if it was 10 times cheaper, and
yeah.
you weren't getting paged in the middle of the night, like
Take the trade off.
everyone's pretty happy with it. They take the trade off. It's funny. People are like, no, I want to use it for this use case because it's great and it's not latency sensitive. I have this other use case, it's latency sensitive, so we can't use it there. But like literally while I'm talking to them, they'll talk themselves out of it. They'll be like, 10 times more expensive. Is it that latency sensitive? Like I'll see it happen, you know?
Yeah,
So it's
yeah,
kind of funny. So that was kind of like an aggressive, which was like, we believe that wasn't super clear when we, were pitching investors and talking to potential customers and stuff like that. Cause it's like, it's not until you like put stuff out there that you really know. But that's what we
yeah.
felt. So that was part of it. The other thing you're talking about, accomplishing it sounds simple. It's this weird kind of knot, right? Where it's like if you start from first principles, you're like, okay, the kind of naive way to do this is like just make a file every 250 milliseconds for every topic partition. And like you said, then
Yeah.
you immediately run into this problem of like, okay, now I have two major problems. One is okay, but I have multiple agents that are producing data
Yeah.
for the same partition. So how do I decide
Yeah.
which of those files is first?
Yeah.
Right? And then it's like, oh, I could have a leader, but now you've introduced leaders, right? And we don't want
Yeah.
that.
Yeah.
That's one problem. And then the other thing you're like, okay, well, I can just shove a bunch of data for different topic partitions into one file, which is what we did.
Yeah.
But then once you do
Yeah.
that, you're like, a bunch of stuff falls out of that because like I can't just like tail the files in object
Mhm.
storage and read a partition from
Mhm.
start to finish. So now you create this like, oh, okay, I need to track metadata, but it's actually a really
Yeah.
big metadata, high volume metadata scenario that you need to solve.
Yeah.
And then you get into that and you're like, okay, how do I solve the high volume metadata scenario and how do I keep things cost effective? And you just have to keep pulling on this thread.
Yeah.
Um, and they're all solvable problems. There's kind of little tricks for each piece. But by making that one trade off, you end up with something completely different. And that's kind of like a lot of times people ask me, like, what's the difference between like WarpStrem and doesn't Kafka have tiered storage? And I'm like, tiered storage works, but it's like you're still copying all the data across the zones and you still have to deal with top
Mhm.
leaders and you still have all the problems of Kafka. You're just essentially cutting off the storage problem.
Yeah.
But as
Yeah.
soon as you get from like, you want to go from like, even if you get it down to like, I'm storing 5 seconds of data on disk and everything
Yeah.
else gets
Yeah.
copied to S3, going from five
Yeah.
seconds to zero means you have to throw the whole thing away and start from scratch
Yeah.
because you've just
Yeah.
introduced a bunch of other things that have to be solved. And so it's a combination of things. I think it's being willing to be aggressive on that latency trade off. It's basically being able to work through kind of from first principles all of the little problems that latency trade off
Yeah.
introduces and the stateless nature. It's kind of hard to commit to making such an aggressive trade-off and being willing to work through those first principles. When we started the company, like Ryan was like, "Here's the napkin math, it'll
Yeah.
work," and I'm like,
Yeah.
"That's cool, but will it work?" And he's like, "I don't know."
Yeah.
Uh,
Yeah. Exactly.
and so that's hard. And I've had that with every new system I worked on too. I mean, there were periods of time when we were, let's say like a year and a half into Husky before it had really gone to production, but we'd spent a bunch of time on it and we were still dealing with some like major performance problems and stuff.
Yeah.
And we're just like, is this going to work?
Yeah.
Like, you
So
start to
so
doubt yourself, and
yeah.
so it's hard. I don't know.
I guess how long did it take from that napkin math moment of like, and I'm guessing what you're thinking about is, well, here's what we know about S3 latency, on the storage class, here's what we know about network times. And so here's the like end to end latency we estimate. Do you have a sense of like how far off you were from where WarpStream is in production today to where that estimate was, and like, have there been step jumps in? Okay, like prototype one was 100x what we thought it would be, and then when we like slowly iterated, maybe switched metadata stores, switched the way that you copy data, that something significantly changed.
Yeah. So there's definitely like for sure if you compare the early prototype to now, like the first prototype, if you had like 1,000 partitions, would just like immediately explode, right? So there's definitely like stuff like that that we fixed, and especially around scalability of the metadata store, also making that cost effective, so we can offer this really truly multi-tenant serverless scale to zero thing. One thing we considered really early on was using Foundation DB as the metadata
Yeah,
store.
yeah,
And I think if we'd built WarpStream at like Datadog, that's what we would have done because it's there. We know how to
yeah,
operate it, and you can just deploy a Foundation DB cluster, and because you're gonna have it's gonna power this giant other workload, and so the costs there are minimal. But if you
yeah.
want to do like some customers send
I
half a
see.
megabyte per
Yeah,
second, and some send 5 gigabytes per second, and you
yeah,
want to give them something that looks kind of single tenant, isn't just a giant shared FTP cluster,
yeah.
where you're gonna have all these noisy neighbor problems. That's why we built something custom,
Hmm.
is to deal with that. But going back to the early prototypes, we basically spent the first 3 months of the company doing nothing but basically trying to prove that the napkin math was right. We actually managed to do a little bit better on end-to-end latency than we thought we would be able to, because we were a bit conservative in our estimates. Um, but yeah, like literally the first 3 months of the company's life was basically us just trying to prove it would work and de-risk things.
Yeah,
Um, the most of the stuff turned out to work. I think we ended up did realizing some problems were way harder than we thought they were. The problem that ended up being way more complicated than we thought, and we didn't anticipate how complex it would be, was actually how we would do compaction. This would be like a whole thing, so I won't get into now. But the way that we do compaction planning for WarpStream is really weird, and it's like basically I think a relatively novel algorithm for
hmm,
compaction planning that makes sense because of the semantics of like Kafka, but is not
I
something.
see.
If you look at WarpStream, it kind of looks like a traditional LSM on S3, right? Like you make small
Right,
files and we compact them into big files.
right.
Um, but because of the kind of ordering semantics of Kafka, you have to be really precise about which files go together and when. So that was a
Yeah,
part that we ended up spending way more time on than I thought, and we ended up having to kind of like scratch our initial implementation and
yeah,
redo it. It had
yeah,
one or two of those existential like, is this going to work moments
yeah.
and stuff. But
So actually, one thing that's interesting about that is if you think about the contract of a system like Kafka, um, you could almost say that latency is part of the contract, and that's the part of the contract that you've relaxed a little bit, right? In order to rebuild uh, with the same protocol, but clearly you're not trying to relax a bunch of other constraints. Um, has that ever been a thought of like, oh, what if we didn't keep the, I don't know, partition order, or what if we didn't keep this other property? Uh, is it just that, like, that would violate how existing applications use Kafka, and so it's just a non-starter? Or is there something like that where you're like, I don't know, Kafka has this specific item potency or exactly one semantic that we're just not gonna support because, we don't think most people need that, just like in the way that most people probably don't need the end-to-end latency that they're getting.
yeah, we definitely considered that. I mean, there were early designs where we like didn't have monotonically increasing UN64 offsets.
Yeah.
The first protocol we actually started with, I guess I didn't explain this, was actually not Kafka, it was Kinesis. So the
Hmm.
Kafka protocol is extremely complex. So we started with Kinesis, which is an HTTP protocol, to prove out
Yeah.
the rest of the semantics of the system. And so we definitely had thoughts about dropping a bunch of some Kafka features which are particularly um, annoying to implement in
Yeah.
a stateless architecture. And I think again that's another thing. Like if we had built this at a big company, we would have done it. Like we would have done the easier thing because who cares? I can rewrite my application or I can write a client wrapper. Right? I control the
Yeah.
system end to end. And you've seen that, like Pinterest has a system called like MQ, which is
Mhm.
essentially like they wrote client wrappers and they upload file to S3 and then push a pointer to it through Kafka. And
Yeah.
it adds like additional zookeepers and it makes the thing more complex. But even at a big company, you can afford that complexity to not have to
Right.
do all the crazy stuff WarpStream does.
Right.
But I think the more Ryan and I talk to each other and to customers and like looked at the Kafka ecosystem, there's not much you can throw away and still have most applications work.
Yeah.
Even
Yeah.
like the latency trade-off we made, it's a relaxation, but a lot of people tune their Kafka clients to buffer and batch for a
I
long
see.
time anyways,
Yeah,
because it
yeah.
reduces costs and performance. And so that was kind
Yeah,
of just like it's like almost like a knob. But stuff
exactly.
like item potent producer, even compacted topics. We're like compacted
Yeah.
topics. Who could possibly be using compacted topics? Like our naivety coming from Datadog because it's like we don't use Kafka as a KV store. But it turns out
Yeah.
like a lot of stuff in the Kafka ecosystem uses Kafka as a KV store. After we started the company, we're like, wow, Kafka Connect, Debezium, Kafka Streams,
Yeah.
none of this stuff works without Connect compacted topics. Yeah, I think we would have liked to. I just don't think we really had the choice. All the value in this stuff is like it's cool, the statelessness and blah. But like if we didn't implement the Kafka protocol, it would be like a cool
Mhm.
science project, right? The
Right,
full
right.
support for Kafka protocol compatibility is to me what makes it a business. And it's
Yeah.
like that unsexy part of it that makes it, that's what lets you sell it to people and continue developing it. So
Yeah, and we've been talking about the sort of complexity, and even the sort of infrastructure that small teams can afford to reason about or run, versus large teams who can, do things like spin up a foundation DB cluster, and then obviously they're just working with a different set of trade offs where they're not building a multi-tenant environment. So tell me a little bit about, and I've heard you talk about this elsewhere that smaller teams can just build more ambitious products today. Obviously, WarpStream, very very core technical infrastructure is a very ambitious product. Where do you think that leverage is coming from? Is it just the composability of these cloud providers who have built, progressively better primitives?
yeah, I mean that's what I think. Like I think this is a different interview. I'd be talking about AI right now. I have found AI to be supremely unuseful in building infrastructure software. So, but people sleep on like what you can like. I mean, we have like some Terraform modules written by like two people basically that
Yeah,
stand up production grade enterprise whatever infrastructure it creates. I mean, the way you can program networks in AWS with like a couple lines of Terraform code is like magic, right? Like if you
yeah,
think about
yeah,
what you'd have to do to accomplish that level of sophistication in like a colo or whatever. Even
yeah,
with WarpStream, like our entire control plane has and like backend, like besides essentially our Aurora database for storing like what customers we have, there are no
yeah,
disks anywhere in the entire stack. I could go wipe every container in our backend, and it would make a bunch of people very unhappy, but there would be no data loss. Everything is
yeah,
built on cloud primitives like object storage and DynamoDB and stuff like that. And the fact that you can just get those things, pay for them in like a
yeah,
serverless manner, and get going, it's absolutely crazy. I think it's
yeah.
easy to overuse those things and introduce a ton of complexity. I've talked to some people and it's like, it's like a 6-person startup and they have like, you know, 40
30 data
repos
stores.
and yeah, yeah, and it takes like there's like 30 microservices. I'm like, what? Um, and so but I think if you like kind of know what you're doing, you take a couple key dependencies on really battle tested, scalable, good stuff, like object storage, DynamoDB, application load balancers, that sort of thing. And you try and stay within the confines of those primitives, you can build really crazy stuff.
And
Yeah.
in fact, you all have built two different versions of WarpStream today, where there's a kind of bring your own infrastructure. And my understanding is in that model, you're deploying WarpStream on, basically Kubernetes in the customer's VPC, and then there's like a fully serverless hosted by WarpStream model. So let's talk a little bit about what are the architecture differences and why choose to build both, especially when you all are, still pretty early, still trying to understand the viability of the core offering. So why build both from the get go?
Yeah, that was actually a really tough call, and I wouldn't say we did it from the get go, but we did do it pretty early. We started with just the BYOC product because to me it's like the most differentiated product. Like the fact that you can just get something that runs completely in your environment, but
Yeah,
is so simple that like it's as if you have a SaaS, but you don't. Like your data
yeah,
never leaves your cloud account. You have complete data sovereignty. It's all in your bucket. All the consensus is handled remotely. You don't have to think about that. You don't pay for any interzone networking fees, and it can actually be 5 times cheaper than running open source Kafka in your own environment. To me, that's like a very, very, very differentiated and clear product. And whereas the serverless product is like once the Kafka protocol is hosted by somebody else, the differentiation becomes less obvious. You're differentiating on other things. Scale to zero, it's price, it's not as clear, right?
Yeah.
And
Yeah.
so we didn't start with a fully hosted serverless product, but the thing we kind of kept running into was that, our pitch is that it's the easiest way to do Kafka. It's the easiest way to do streaming,
Yeah.
and
Yeah.
like even just deploying some stateless containers into your environment. Maybe
It's
needing
not
to talk to your
trivial.
boss. You got to figure out the
Yeah.
chart. You got to do some Terraform. Yeah. Whereas like click a button, Kafka is a URL, just get some credentials. That's easy.
Yeah.
It just helps us engage with smaller customers. We've gotten a ton of
Mhm.
feedback from people where it just doesn't make sense for them to deploy the containers themselves, but they use our serverless product in production and they're really happy with it.
Yeah.
I think we've differentiated the product enough with the scale to zero and the way the pricing works. But it's really just about, I think, like kind of that mission of making it as simple and easy as possible. We had to, I think, have that offering. And there's a really nice story, right? Which is like if you're small scale, where the pricing and the networking fees don't matter, you can get these serverless clusters. They scale to zero when you're not using them. Even if you
Yeah.
do encounter some decent traction and you take off, the pricing's still pretty reasonable.
Right.
And then when you're ready, if you mature as an organization, you can always move to BYOC and run your own
Yeah.
agents.
Yeah. So let's actually talk about the pricing part of WarpStream, just because that is also a core focus of the value prop, right? So how do you think about pricing for serverless versus BYOC? Where have you put in more energy? And it doesn't have to be exact price points. Like obviously those will evolve over time as the product evolves. But um,
Yeah.
yeah, like how did you think about that?
Yeah. So the thing we knew when we started this was we wanted to have very predictable and transparent and what we considered, fair pricing. Fair is probably not the right word. Principled is probably a better word.
Hmm.
Um, but like we did not want to be the, I won't name any names, okay, but we did not want to be the like really expensive bougie vendor that only the people who have lots of money to burn can afford to use. Basically,
Right.
we wanted to be the AWS in this space. We wanted to be like, you're paying money for it because it's a good product and people need to stay in business, but it is a core primitive that you can scale your business on. And it's not like,
Yeah.
oh, if I have really high scale, I have to go back to self hosting, right? The way we thought about it, we also like, I hate when things are priced like per core or
Okay.
per node or something. I hate that stuff because it's like, especially for infrastructure, because I'm like, you're writing the software. It's your job to make it fast. Why are you charging me because your software's slow? Like that's
Yeah. Yeah.
dumb. We
Yeah.
should both be incentivized to make the software fast, right?
Yeah.
And scalable. Especially with our architecture where it's stateless. I tell people all the time, you can have these nodes only handle writes and these nodes only handle reads and these nodes do background jobs, and now you have full isolation between your writers and readers. And like
Yeah.
that sounds scammy if I'm also telling you, but I'm going to charge you 3 times as much to do that, right? You shouldn't have to pay 3 times as much to do that. Um,
Yeah.
and so what we settled on was a usage-based pricing model where um, everything's metered, and for the BYC product, it's only on 3 dimensions. It's like it
Mhm.
just if you have a cluster and it's doing stuff, that's $100 a month. It's
Okay.
metered in 15-minute increments, but just some overhead for small clusters because of how our metadata store works. And then we just charge you for how much data you write and how much data you store. Um,
Right.
and the kind of principled approach I took at the time was like I estimated how much it costs to run a self-hosted Apache Kafka cluster at a certain scale, and that's where our
Yeah.
pricing started, basically.
Yeah.
And I'm like, you're getting a much better product, and it's the exact same price. But then as you like abuse it and use it at scale, the
Yeah.
price tiers super aggressively and in public, right? You don't have to go argue with a sales guy for 2 years to get the price to go down. It's like you can look at it, project. If I'm a successful company and this use case grows, here's how much
Yeah.
it's going to cost,
Yeah.
and that's public and on our website. And to me, that's like if you're doing core infrastructure, you're trying to sell to infrastructure engineers. It's got to
Yeah.
be like that, right? That's how AWS does its pricing. I mean, AWS doesn't have super public tiers, so but close, right?
Yeah. Yeah.
Yeah.
Let's talk a little bit about the fact that, in WarpStream, I think regardless of the architecture, right? WarpStream, your infrastructure, your metadata store in particular, I think, is in the critical path of any read and write request, right? That's a lot of responsibility. And I'm wondering, especially again, for something so core to someone else's technical stack, um, how are you navigating that problem? Is that an objection you have? Is that something where people run stress tests and you can kind of just prove out reliability? How do you maybe on a technical standpoint think about reliability, and then from a kind of go to market sales standpoint think about the talk track around it?
Yeah, the it's a really good question, and I think I don't know if that's like a thing we'll ever. There's no like checkbox answer. It's kind of just like
Yeah.
something that has to be part of our core philosophy, part of our core engineering culture, and we just have to kind of like live and breathe for the rest of the company's life. I think from a technical perspective, I've worked on tons of systems like this. Datadog was really critical. I mean, I still remember when um, there were times when Datadog incidents or things went down, you would be surprised at the things in the world that have to turn off because they don't have visibility.
Yeah.
And that was a lot of pressure that Datadog bore. Same at Uber, right? People get stranded in the middle of nowhere. You think you're just running some back end, but there's someone drunk 2 in the morning, maybe in an
Yeah.
unsafe area. And, they can't get a ride home or whatever. Um, and so that's been, I think, baked into the company culture very early on from like a pure technical perspective of how we do it. There's the obvious stuff about relying on really scalable, rock solid primitives, having good rate limiting in place, structuring everything so that there's isolation between tenants. We're really big fans of the cellular architecture.
Mm.
Datadog is a heavily, heavily cellular based architecture. Um,
Mm.
WarpStream is and will be the same, which is basically you have these cells, and a cell is like a copy paste of your entire infrastructure stack, and a cell may
Yeah.
be multi-tenant, and there's a bunch of constraints within that cell to prevent anyone from using too many of the resources. But on top of that, like cellular boundaries are hard boundaries, and no matter what someone does in one cell, it can never impact another cell.
Mhm.
That's really,
Mhm.
really, really helpful because it just reduces blast radiuses when things do inevitably go wrong.
Mhm.
Um, and so all of those things. There's also like for kind of like bigger workloads, we have stuff like single tenant control plane cells.
Mhm.
So, if the workload's big enough or the customer is willing to pay for it, basically, we can give you essentially a completely isolated stack. And
Yeah.
that sounds crazy, but because of the architecture of the product, it's not really. You add one more thing to an array in a Terraform provider, and it's not like there's more nodes that we have to rotate or anything. It mostly manages itself. And then also just because of the simplicity of the control plane at even really, really, really mega scale, it's tenable for customers to self-host the control plane. It's not what I generally recommend to people because it's like you're probably not going to be nearly as good at operating it as us. But there are certain environments, things need to be air gapped, whatever it is,
Yeah.
where that makes sense. And so it's something we think about all the time. I mean, a huge, probably more than half of all our engineering resources go into basically resource constraints, limits, rate limiting, all the type of
Yeah.
stuff
Yeah.
there. On the go-to-market side, um, I think a lot of it is just about part of it is having good answers, right? Like a lot of times when I
Mm.
talk to people, they're like, "Okay, so how does the control plane work?" And if the answer is like, "Oh, we like have these custom RAF nodes that we run with like local disks, and like I've got this guy and he's really smart," that's not a super satisfying answer. But when I tell people everything is like we run 4 replicas per tenant of the control plane, and the only dependencies we take are on that the network in AWS needs to work and object storage and DynamoDB need to be up. And even if object storage
Yeah.
is down, we can keep running for a while, but DynamoDB needs to be up. They're usually very happy. A lot of
Yeah.
these
Yeah.
people like they're running in AWS. They know how rock solid that infrastructure is. They know that they're
Yeah.
not going to run anything more reliably than AWS, and that's a satisfying answer. Sometimes it goes a little bit beyond that, and I think a lot of it too is I think about your brand and reputation as a company too. Do people trust you?
Yeah. Yeah.
There's a lot of companies that no one thinks twice about putting all their company infrastructure in AWS because AWS has a really good brand. They take incidents
Yeah.
seriously. AWS is an extremely multi-tenant environment, but you know that
Right.
they have like they've written their own hypervisors and they've done everything they possibly could to make it good and scale,
Yeah.
and that just comes with time and brand and reputation. And
Yeah.
I think that's
Yeah.
something we talk about a lot in the team too is that the way we put ourselves out there in the world needs to, I don't want to be like
Reflect that.
overly serious, but we need to be professional and we need to,
Yeah.
eh, people need to trust us and we need to do everything as responsibly and securely as we can.
Yeah.
And not caught up in stuff that can happen on the internet when people aren't being
Yeah.
professional, basically. Yeah.
Yeah.
Um,
All right. Well, maybe on a slightly less serious note, last thing I'll ask: what are you most excited about? It could be a technical problem you all are working on, a new feature rollout. What's coming next? Where are you putting at least a lot of the positive energy
yeah.
at WarpStream?
Dude, we got so much good stuff coming out. We're sponsoring Kafka Summit in London, March 20th. We're about to roll out. I just launched it actually, like infinite retention to all
Oh, nice.
customers, so you can do that now. We're going to roll out full support for compacted topics in Kafka, so you can use us as a KV store if
Yeah.
that's what your heart desires. Our implementation of compacted topics is actually really good. I'm really excited about it. We put a lot of engineering effort into making it good. It's not like a half-baked early release. I'm really excited about that because that opens up a whole new world of the Kafka ecosystem that can use us.
Yeah.
Our serverless product is still kind of in alpha, but we've started getting a couple people in production. I'm looking forward to maturing that. The BYOC product is going to go GA in March. I'm really excited about that too.
Nice.
And I think kind of Q2, Q3, we're going to start looking a little bit beyond the Kafka protocol. Um, and I think that'll be really cool. Stuff like server-side partitioning, native
Yeah.
iceberg integrations, that type of stuff. Stuff that really like allows you to do new things that you just can't really do
Yeah.
with
Yeah.
traditional Kafka today, instead of just being a cheaper, easier to run mousetrap. Um, so we got a lot of really cool stuff coming down the pipe.
Awesome. Well, that's very exciting, and it was great having you. Thanks for coming on.
Thanks for having me, man. This is great.